winter storms, forest fires, the apocalypse. Climate change. Is it real? Is humanity to blame for the rise in temperatures over the last 150 years or so? And if so, is there a way for us to fix it? Or is humanity leading the world into its sixth mass extinction with unimaginable consequences? And what is climate change? How is it different than global warming? First, let's look at the definitions of climate change and global warming, just to set the record straight. Well, to begin with, global warming refers to the rise in global temperatures due mainly to the increasing concentrations of greenhouse gases in the atmosphere. Climate change refers to the increasing changes in the measures of climate over a long period of time, including precipitation, temperature, and wind patterns. So, while global warming is what many people call it when they reference the potential catastrophes in our future, climate change is all-encompassing, as it includes the whole picture. It is more complete when studying to hypothesize the effects of global warming and higher rainfall rates in storms that may lead to flooding, stronger storms, droughts, and the impacts long-term. Next, let's look at some of the science to see what sense we can make of climate change. The Earth is warming. There's no arguing that point. Global temperatures have risen around 1.1 degrees Celsius since 1850. However, there are some, mostly people who seek political or financial gains, who have muddied the waters with this information. They claim that Earth has warmed before due to natural cycles. While that's partially true, the climate during humanity's brief existence has been generally stable. And we have found that throughout history, any quick changes in climate, and just by a degree or two, has led to mass human suffering and downturns in civilization. Today, a sudden shift in climate would disrupt civilization as we know it, and even humanity's survival. We'll discuss that more at a later time. Back to the science. 97% of publishing scientists agree that humans have changed and continue to change the climate by pumping fossil fuel emissions into our atmosphere. The other 3% lean toward the natural cycles Earth goes through, or lack of sunspot activity, and the like. However, it is absolutely clear with concrete evidence that historically, when global CO2 emissions were high, so too were the temperatures. So, the Earth has warmed without humanity. That's true. But we have gone far beyond any CO2 emission levels ever found in historical data. We are in uncharted territory, not only for humans, but for all life in all of Earth's history. We've already discussed that Earth's global temperature has risen around 1.1 degrees since the beginning of the Industrial Age. In 2018, the Intergovernmental Body of Climate Change reported that by 2100, a 1.5 degree increase would cost the world around $54 trillion in damage. The figure jumped to $69 trillion, with temperatures increasing to 2 degrees. It's apparent from just an economic standpoint that change is necessary. But there's more. It is believed we are on pace to hit 2.7 degrees at our current rate, and if we do nothing to change our trajectory, 4 degrees is very possible. Furthermore, there are 2 degrees or more baked into our oceans that will be released into the atmosphere at some point. The oceans are great CO2 collectors, but they don't keep these gases contained forever. To further complicate future predictions, warming has begun to accelerate faster than expected, and as a result, melting of glaciers and permafrost may be 30 years ahead of schedule. We'll get into that in more depth later too. So let's see how we got to this place and look at our history. In the mid-1700s, before the Industrial Revolution, CO2 stood at approximately 280 parts per million in Earth's atmosphere. Then, humanity embarked on an age of industry, helped by coal and oil. These fossil fuels were plentiful and were key in rushing the world into an age of new technologies and wealth. In the mid-1900s, after 100 years of unchecked pollution, CO2 levels had grown to just over 300 parts per million. We've recently gone over 400. CO2 output has increased with population and humanity's demand for industry, heating, and transportation. The ties between the increase in fossil fuel emissions and climate change hadn't gone unnoticed either. When scientists began chatter about climate change in the mid-1900s, it was new and startling. They clung to dogma then, much as they do now, many unwilling to challenge the status quo. Also, prediction models couldn't be made without computers and a bit of history to gauge change against, and therefore considered unreliable. The predictions had too many unknowns. By the 1970s, more scientists came forward, but still reported future events conservatively. In the 1980s and 1990s, governments were becoming more aware of climate change, but still valued immediate concerns over a possible scenario based on non-alarmist reports presented by scientists. The scientific community found that they weren't taken seriously if they came forward with earth-shattering foretelling. They downplayed predictions so governments wouldn't dismiss them as doomsayers and would actually take heed, but that may have also helped in leading to years of inaction. More recently, most of the scientific community has gotten on board and even helped bolster their science with economic impact reports. But the world pumps 40 times more greenhouse gases into the atmosphere than it did in 1850. Now governments are listening. But is it too late to make the changes necessary to avoid worst-case scenarios? Why do we need change? What could possibly happen if we do nothing? Pollution alone kills around 7 million people worldwide each year. One would think that would be enough to make changes. We mentioned a few minutes ago that a sudden shift in climate would disrupt civilization as we know it and threaten humanity's survival. Slower change would still be catastrophic too, though. Civilization is based on constant temperatures and weather patterns that allow agriculture to flourish. Even mild changes would disrupt the food chain to some degree. Local to regional harvest failures would become common, impacting people's ability to live comfortably. As in most cases, the poor would suffer the most, more so than the middle and upper classes. The potential for third world countries to be devastated by even mild changes is a real possibility. Water rise alone threatens many island nations, Bangladesh, the Netherlands, and many coastal areas around the world. Right now, the Greenland ice sheet is disappearing 4 times faster than in 2003 and already contributes 20% to current sea level rise. Moderate climate change would tax the middle class too, with regional to national food shortages. Agricultural prices would skyrocket. Finding food would become a real challenge to feed everyone. At this point, mass migrations would begin, putting further pressure on already burdened areas. Fresh water would become harder to find in many mountain areas because mountain glaciers are disappearing and may be gone by 2100. They have been melting quicker than first predicted and losing ice at accelerated rates. Many of these glaciers supply fresh water for people and all life forms to live. The United States desert Southwest is an example of reliance on mountain glaciers for survival. 2.7 degrees would be considered catastrophic. That's the path we're on, with 4 degrees or more possible. Most equatorial areas of the world would be unlivable. Food shortages would be massive. Wars would be fought to control water and food. 1 billion people could be displaced. Many more would die. In The Future Life, 2002, Edward Osborne Wilson of Harvard calculated that if the current rate of human disruption of the biosphere continues, 1/2 of Earth's higher life forms will be extinct by 2100. Let's look at glaciers. Most of the world's freshwater ice is held in 2 places, Antarctica and Greenland. These massive areas of ice are unlikely to completely melt by 2100 and cause over 200 feet of sea level rise. But earlier estimates of 2 to 3 feet rise by the end of the century seem way too low. The U.S. National Oceanic and Atmospheric Administration projected in 2017 that global mean sea level could rise 5 to 8.2 feet by 2100. 4 years later, and it's clear that 8 feet is in fact a moderate projection. And regional influences, subsidence, changing ocean currents, and redistribution of Earth's mass as ice melts will cause some local sea level to rise 20 to 70% higher than globally. Scientists are alarmed by how entire ice sheets, like Antarctica's west ice sheet, is being compromised by warm waters eroding it from beneath. No longer are they only concerned with melting from above, but also from this newer discovery that could raise sea levels an additional 20 feet. The Intergovernmental Panel of Climate Change says, beyond 2050, uncertainty in climate change-induced sea level rise increases substantially due to the uncertainties in emission scenarios and the associated climate changes, and the response of the Antarctic ice sheet in a warmer world. Furthermore, melting of polar ice becomes a feedback loop that keeps the cycle progressing on its own. White ice reflects much of the sun's heat back into space, but as more of it melts, the darker ground and seawater absorb more heat. This cycle continues to accelerate and support the process as more ice melts, revealing more dark surface to absorb more heat, and so on. Melting of enough freshwater ice from Greenland into the North Atlantic could shut down the Gulf Stream conveyor belt that brings comfortable temperatures to Europe from America's warmer Gulf waters. If this happens, Europe, which is at equal latitudes to Canada and Siberia, could be plunged into similar temperatures. How much heating the Arctic will experience to offset Europe's potential freeze is troublesome. That's just CO2 emissions so far. Methane is another greenhouse gas that causes warming, and it accounts for more than 20% of global emissions. Much of it comes from livestock, cattle in particular. What's so troubling is that over the last 2 centuries, methane concentrations in the atmosphere have more than doubled, largely due to human-related activities. And the more the planet warms, the more methane is released into the atmosphere from the frozen ground in the Arctic, known as permafrost. Predictions on melting of permafrost is also on an advanced schedule, coming 30 years before predicted. Towns are beginning to collapse into the softer, unstable ground as it thaws. There will be a point when we can't stop the melting, and better have CO2 under control at the very least. Yes, this is another feedback loop that emits methane, causing more heat, which causes more melting, and the cycle continues. The good news, if there is any, is that unlike CO2, which stays in the atmosphere for hundreds or even thousands of years, methane only remains for 12. So, we know why we need change and what could happen if we do nothing. But what can we do? Well, before we can answer that question, let's look at some numbers. We've established that fossil fuels are the largest cause of climate change. In fact, most of the power we generate comes from them. The world's power supply is based on 33% oil, 27% coal, and 24% natural gas. That's 84%. The remaining 16% come from cleaner energy, like 7% hydroelectric, 5% alternatives, and 4% nuclear. Based on these initial numbers, it's clear we need to switch from fossil fuel use to other means. But it's more complicated than that, and the math becomes staggering. The Energy Information Administration has released data showing that the transportation of people and goods accounts for about 25% of all energy consumption in the world, and that passenger transportation, in particular light-duty vehicles, accounts for most transportation energy consumption. To go green, we need to delve deeper. Let's take a look. Global electricity production is currently comprised by 63% fossil fuels, 27% renewables, and 10% nuclear. That's just our electricity, If we want to convert our transportation to electricity to eliminate gas and diesel, the electrical load needs to grow substantially. Not only do we need to close fossil fuel plants and replace them with cleaner plants, but we need to add many more for the extra burden of transportation. Also, this is the current load. Electricity usage grew by 73% in the last 20 years. It will continue to do so as population and demand grows. We also need crystal balls to anticipate how much we actually cut by changing our lifestyles. We'll get to that in a bit. Let's start by replacing coal plants with nuclear. They're the dirtiest and one of the least efficient, while nuclear power is one of the cleanest and most efficient types of energy available today. An average nuclear capacity factor of 91% beats other energy forms by a substantial margin. Natural gas produces an average of 50%, while coal produces energy at almost 59%. Many people argue that nuclear is dangerous and produces highly radioactive byproduct, but newer technology solves most of these issues. Plants can reuse spent uranium and use liquid sodium cooling. They are much safer and cleaner than the 50-year-old technology we have been using. There are over 5,600 coal power plants in the world today. We would need roughly 2,800 nuclear plants to replace them. At a cost of roughly $8 billion each, that's a staggering $2,240 billion. Let's replace oil. Well, that's also difficult. For one, the price is extraordinary. Trillions of dollars. Land is the next problem, if you can call it a problem, compared to a mass exodus and suffering on an unimaginable scale. Basically, we need to cover an area the size of Italy with clean, unobstructed solar panels. Replace natural gas with hydroelectric and wind, and we are almost there. But we need to double our electric grids and update and install batteries to store electric during times of calm for wind power and at night for solar. In the event of power shortage, we would have to have contingencies in place, such as more nuclear power plants and alternatives. This price tag is also in the trillions. We'll round things out and use carbon capture to pick up anything we've missed or for projections that fall short. We now have giant machines that can catch carbon. Planting more trees is a natural way to absorb more CO2 as well. Completely switch over to electric cars. While still more expensive than gas and diesel vehicles, and needing charging stations everywhere and a network, we will save 12% of energy worldwide. That accounts for most of what we need to do as part of a large-scale plan. The range of estimates on costs to mitigate or limit climate change are all over the map. There are debatable ranges of $73 trillion to $150 trillion. The International Renewable Energy Agency, an intergovernmental body, estimates that the world needs to invest $115 trillion in clean technologies such as solar and wind power and electric vehicles to limit global warming since 1900 to 1.5 degrees Celsius, the goal of the 2015 Paris Climate Agreement that was signed by 195 countries. But, according to Bloomberg's most recent 2021 opinion, stringent climate policies would reduce the temperature rise to 2.2 degrees Celsius, but cost $177 trillion to reduce climate change-related damage from $140 trillion to $38 trillion. That would raise the total cost to $215 trillion. Is this even feasible? If it costs the world hundreds of trillions of dollars to do nothing and watch the horrors that would unfold, it has to be. Here's how, and it's the only way. The wealthiest nations in the world are by far the biggest contributors of CO2 emissions. The United States is the largest contributor of CO2 in the world's history at 25%. The 28 countries of the European Union contributed 22%, and China added 12%. India, Brazil, and others are climbing fast, but haven't contributed nearly what the others have over time. We can't expect the US, Europe, and China to foot the bill for the world, even though they are the reason for climate change. They account for 59% of the total CO2 in the atmosphere. And while they have benefited the most from industrialization, they don't have the means to ante up. That's unfortunate, because it tasks the poor countries to suffer even more. How hard will it be to pay for change? Take, for instance, the world GDP. It's currently around $94 trillion. That means that each year, the world only produces 44% of the total $215 trillion Bloomberg states is needed. Although the US, China, and Europe have massive economies, consider this. The US GDP is around $23 trillion. Its debt is around $29 trillion and climbing fast. It is barely sustainable, let alone forced to pay its fair share of $54 trillion. A 2017 study in the journal Science found that for every 1 degree Celsius, or 1.8 degrees Fahrenheit, that the planet warms, climate impacts could cost the United States roughly 1.2% of gross domestic product. A 2019 working paper for the National Bureau of Economic Research put that number even higher, finding climate change could cost the United States up to 10.5% of GDP by 2100. And remember Greece filing for bankruptcy a decade ago? A deep recession cost the world trillions of dollars. In fact, the total of everything that we own and have produced that we have today on Earth is $360.6 trillion. To put this into perspective is mind-boggling. 2/3 of everything on Earth that we own is the equivalent of what needs to be paid to stop climate change. It's not that cut and dry, of course. The number changes by a couple $1 trillion every year, but it goes to the point of just how dire things will be if we continue to wait and not tackle the problem of climate change head on. This makes it tougher. We don't have until 2100. We don't have until 2050. Experts believe we have around 8 years to put everything in place to mitigate disaster. We're already seeing signs of hitting at least 2 degrees, no matter what we do. So how do we fix this? We can't, at least not completely. But here's what we can do. We need the buy-in of almost every person on the planet. Yes, even the naysayers. We also need the buy-in of almost every government, at least the wealthiest ones. It's up to us to force them. But let's knock the price tag to slow climate change to $100 trillion. That's not unreasonable, considering many of the economic impact reports aren't much higher than that, without the cost of damage and loss from climate itself. Each nation pays its percentage of CO2 proportionally. So the US would pay $25 trillion over 8 years, or $3.125 trillion per year. Europe pays $2.75 trillion, China $1.5 trillion, and so on. Each nation would have to contribute an additional 25% of those costs as reclamation for nations facing immediate sea level threat, famines, and floods every year after year 8. It's terribly expensive, but if China agrees to release some of the worldwide debt and nations can change how they operate, this can work. To further break down things, collectively, we heavily tax and tariff oil, coal, and natural gas companies while subsidizing cleaner alternatives. They were aware of damage they were causing. Exxon knew 40 years ago. Power companies get treated the same. We force the wealthy to pay their fair share of taxes worldwide, charge industries based on CO2 output, and offer better incentives to individuals with cleaner living. Prisoners can work to cut on costs, have the military build plants and infrastructure. Volunteer programs could be incentivized. Gas taxes on vehicles or individuals with excessive mileage should be implemented. These are just some of the things we can do. If governments transition to vegetarian incentives, overpriced dairy products, place additional fees on processed foods, and illegalize livestock farms, the world would be much better for it, cleaner, and it would help with animal suffering. Now, while going vegetarian seems extreme, consider these facts. 36% of the world's crops is used for animal feed. 67% of the US Midwest is used for feed. If switched to crops for human consumption, 800,000 more people could be fed. 21 pounds of grain feeds 1 pound of meat in return. In fact, livestock takes up 80% of global agricultural land, yet produces less than 20% of the world's supply of calories. This land could also be freed up for crops, trees that remove CO2 from the atmosphere, and even some of those alternatives we discussed earlier. Many crops can be dry stored locally, as opposed to meat, which requires refrigeration too. It's too much, right? Don't be overwhelmed. We are only talking about doing what's right and what's necessary. So, we can get governments of the world to do these things, and we are almost there. Things we can do as individuals are: shut off lights and appliances not in use when at home or work. Eat seasonally grown and locally grown fresh food. Stop eating processed foods. Stop eating meat. Plant more trees. Commit to lower travel habits, only going out when necessary, and visit multiple places while out. Lower your thermostat temperature in the winter and raise it in the summer, if only by a couple degrees. Use fans instead of air conditioning, or to supplement higher temperature settings. Use timers for your electric devices. Buy an electric car. Don't let water run unnecessarily, and fix that leaky faucet or toilet. Use updated, energy-saving appliances. Use tankless water heaters. Switch to smart thermostats. There are approximately 1 billion households worldwide. Switching would save a stretched budget $700 billion. Peacefully protest. Make governments see we won't wait any longer. Tell everyone you know how important fighting climate change is. Join the empire of Calypso. We can do this together. Hit that like button and subscribe. We can make a difference. Thanks for watching. May harmony prevail.